Good morning, children. So, in the last period, we studied about vectors, their notation, and then different types of vectors, equal vectors. Equal vectors are the vectors whose coordinates should be equal, like that we studied. And then position vector of a point P. Position vector of a point P means it is the vector OP, where O is the origin. Next, we studied about the triangle law of vectors. So, in this triangle law of vectors, triangle law of addition of vectors. In this triangle law of addition of vectors, when you have to add the two vectors, suppose A is a vector like this, A is a vector, and B is another vector like this, then how to add them? They have different positions here. So, what you do is you just draw a vector equal to this, and its initial point should coincide. The initial point of the second vector should coincide with the terminal point of the first vector. This is the initial point of first vector. This is the terminal point of first vector AB. So draw a vector equal to this with initial point coinciding with the terminal point of the first vector. Like this you add. Then join the first vector initial point and the second vector terminal point. So that becomes the addition of vectors A plus B. So like this we define the triangle law of addition of vectors. But definition wise it is like this. If A and B are two sides of a triangle, if AB is equal to A, if AB is equal to A and then BC is equal to B, then AB plus BC is equal to AC. So A plus B is equal to AB plus BC. Okay. So here you should observe that the terminal point of first vector is equal to the initial point of the second vector. That is the main thing you should observe in this property. Now we'll take one example. Suppose I have a vector AB, and then I have another vector BC, and then another vector CD like this. So AB plus BC, what is AB plus BC? AB plus BC is AC. AB plus BC is AC. Again, if you take this side, AC plus CD. Again, AC plus CD. AC plus CD becomes the initial terminal is same as initial of this vector. So AC plus CD becomes AD. So what is AD now? AD is equal to AC plus CD. But what is AC? AC is AB plus BC. Is AB plus BC. AB plus BC plus CD. So you can add 3 or more number of vectors when this condition is satisfied. That is, the terminal point of first vector should be the initial point of the second vector. Again C. So AB, BC, CD. So becomes AD like this. Suppose I have AB plus BC plus CD plus DE like this. If you observe that these are same, then you can directly write this as AE, AB, BC, CD, DE like that. They are same. So it is A. Like this we can easily add any number of vectors and write the resultant vector like this. So this is about the addition of vectors. Next is the properties are like this. Properties. So A plus B is equal to B plus C, and then A plus B plus C is equal to A plus B plus C. So they satisfy the commutative property and also the associative property. This is the associative property and this is the commutative property. Now when you add 0 vector to any vector, you will get A vector. So 0 vector is the additive identity. 0 is the additive identity. 0 vector is the additive identity. Now, for any vector A, if you add minus A, you will get 0 vector. So, minus A plus A. So, that means minus A is the additive inverse of A. Minus A is the additive inverse of A. Additive inverse of the vector A. You have similar things in real numbers also. In real numbers, suppose you have to write the additive inverse of 2. Additive inverse of 2 is minus 2. In the same way, here in vectors also, the additive inverse of A is minus A, like that. Okay, next is we'll find the vector PQ. Now suppose that you have a vector PQ, P and Q. We should find this vector P. Now suppose that OP vector is the position vector of P and OQ vector is the position vector of Q. Now according to the triangle law of vectors, OP plus PQ is equal to OQ. According to the triangle law of vectors, OP plus PQ is equal to OQ. So now what is PQ? PQ is equal to OQ minus OP. So that means it is the position vector of Q, position vector of terminal point, position vector of Q minus position vector of P. So position vector of terminal point minus position vector of initial point. So like this you have to remember. PQ is equal to position vector of Q minus position vector of P. So this is the next point. Suppose I have to find any vector AB. AB means it is the position vector of B minus position vector of A. So like that. So AB vector is position vector of B minus position vector of A. Now this concept you should understand without any confusion. So the general thing is like this. Now see, suppose that you have a vector, a point P. A point P is OP. OP vector is given by some 2i plus 3j plus 4k. So you can write as an ordered triad 2, 3, 4 like this, isn't it? Now suppose that you have another vector Q, position vector Q point. Q is another point. P is one point, Q is another point. So Q is some I minus 3j minus 2k like this. So I can write this as 1 minus 3 minus 2. These two are points. Now in the coordinate plane, you have 2 points P and Q. So that means OP is this and then OQ is this. P and Q are 2 points. Now I should find PQ vector. PQ vector. I should find PQ vector. So according to this, what is it? OQ minus OP. OQ minus OP. OQ means I minus 3j minus 2k minus OP means 2i plus 3j minus 4k. Now it is just like terms you add, subtract like this. So I minus 3j minus 2k minus 2i minus 3j minus of minus plus 4k. Now I terms when you simplify it is minus I and then j terms it is minus 6j and then this is plus 2k. Okay. Now what you should observe here is the points P and Q are in terms of ijk and this is the vector PQ. These are the points. These two are points. They are the points. And here it is the vector PQ. So vector PQ is also in terms of ijk. You can also write minus 1, minus 6, 2 like this, the vector. So in the problems you should read carefully what are given to you, whether points are given or vector is given. According to that you must solve the problem. So points as well as vectors will be in terms of ijk. So this is, you must read the problem properly and see where, if points are given, you convert them to vectors and do the problem. If already vectors are given, the problem will be direct. You may be able to write the, you will be doing writing the steps directly like that. So this is the main difference here. You should understand this point clearly. So points as well as vectors will be in terms of ijk like this. Okay, next is with this all about 15-20 problems. So we'll do the problems. Find a unit vector. Find a unit vector in the direction of the vector. Find the unit vector in the direction of the vector A is equal to 2i plus 3j plus k. In the direction of the vector A. As you already know, the unit vector in the direction of A is A cap is equal to A by mod A. So we'll have, you have A. A is equal to 2i plus 3j plus k. Now we'll find mod A. Mod A is root of x square plus y square plus z square. That means 2 square plus 3 square plus 1 square. That is 4 plus 9 plus 1, that is root 14. So now we'll write the formula and write the answer. So therefore the unit vector in the direction of A is, the unit vector in the direction of A is A cap is equal to A by mod A, that is 2i plus 3j plus k by root 14. That's all. That is the answer. Direct problem. The next problem is find a vector in the direction of the vector A. Find the vector. Find the vector in the direction of. Find the vector in the direction of vector A is equal to I minus 2j that has magnitude 7 units. That has magnitude 7 units. So in the direction of A, you must find the vector which has magnitude as 7. So what you should do is first find the unit vector in the direction of A. Suppose you have a vector A like this. So you must find a vector in this direction which has magnitude 7 units. So what you do is first find unit vector in this direction and then multiply it by 7. That's all. Then you will get the answer. So the unit given vector will write A is equal to given solution. So A is equal to I minus 2j. Now we'll find mod A. Mod A is equal to root of, if this is 1 square plus minus 2 whole square. K is not there, no, so if it will be 0 square because k is not there. So it is root 5. Root 5. Now we'll write the unit vector in the direction of A is the unit vector in the direction of A. The unit vector in the direction of A is A cap is equal to A by mod A. That is I minus 2j by root 5. Now this is just the unit vector. Now when you multiply this by 7 units, its magnitude becomes 7 and you will get the answer. So the vector of magnitude 7. Therefore the vector of magnitude 7 in the direction of A is, in the direction of A is 7 into A cap. That is 7 into I minus 2j by root 5. So this is your answer. The next problem. Find the unit vector in the direction of the sum of the vectors. Find the unit vector. Find the unit vector in the direction of the sum of the vectors. In the direction of the sum of the vectors. Sum of the vectors A is equal to 2i plus 2j minus 5k and B is equal to 2i plus j plus 3k. So as I said, unit vector in the direction of the sum of the vectors. First find the sum of the vectors. So first find out A plus B. Just add them. A plus B is equal to 2i plus 2i is 4, or else write 2i plus 2j plus minus 5k. This is A, and then B is 2i plus j plus 3k. When you add items like that, you will get 4i plus 3j minus 2k. Next, find its modulus. Mod of A plus B. Mod A plus B is root of 4 square plus 3 square plus minus 2 whole square. That is 16 plus 9 plus 4. That is 29. Now we will write the answer. So the unit vector in the direction of the sum of the vectors. Therefore, the unit vector in the direction of the sum of the vectors, or you will write in the direction of A plus B. In the direction of A plus B is A plus B by mod A plus B. A plus B by mod A plus B. So what is it? A plus B is this 4i plus 3j minus 2k by root of 29. So this is the answer. Like this we do. Next. Now we'll do the next problem. Now here we have two problems. I'll write both the problems. You try to understand the difference in these problems. Next, fourth problem. So that the points, these are the points, so that the points A, 2i minus j plus k, and then B, I minus 3j minus 5k, and then C is equal to 3i minus 4j minus 4k. Are the vertices of a right angle triangle. Are the vertices of a right angled triangle. Now the next problem is the triangle formed by the vectors, triangle formed by the vectors 3i plus 5j plus 2k, 2i minus 3j minus 5k, and minus 5i minus 2j plus 3k, equilateral. Now what is the difference in these two problems? Now if you see, here they are the points. A, B, C are the points. Fourth problem. A, B, C are the points. They are the vertices. A point, B point and C point. So that means A point is OA vector. OA is 2i minus j plus k. Similarly, B point is OB. OB is I minus 3j minus 5k. And C point is OC. OC is equal to 3i minus 4j minus 4k, 4j minus 4k. So these are the vertices. Now you must find the sides. You must show that it is a right angled triangle. So you must find the sides AB, side AB or vector AB, side AB, that is AB vector. That is, what is it? OB minus OA. Position vector of terminal point minus position vector of initial point. So AB is OB minus OA. Subtract. OB means I minus 3j minus 5k minus of 2I minus j plus k. So when you subtract, it is I minus 2I means minus I, and then minus 3 plus 1 minus 2j, and then minus 5 minus 1 minus 6k. So this is AB. Now you find the length of AB, mod AB. So that is root of minus 1 square plus minus 2 square plus minus 6 square. So that is root 41. Now you find in the same way BC. BC is equal to OC minus OB. OC minus OB. OC minus OB. That is, directly I am writing 2I minus j plus k. Now we'll find mod BC. That is the length of the side BC. The length of the side BC is root of 2 square plus minus 1 square plus 1. That is root 6. Root 6. Now we'll find BC. Next is CA. CA is OA minus OA minus OC. So OA minus OC. This minus this. So that is minus I and then plus 3j plus 5k. So now we'll find the length. Mod CA is equal to, mod CA is root of minus 1 whole square plus 3 square plus 5 square. So 35, root 35. Now if you see, when you square these two and add, you are getting this 35 plus 6 is 41, no? So you can understand that root 35 whole square plus root 6 whole square is equal to root 41 whole square. So you have BC square. So root 35 means CA. So CA square plus BC square is equal to AB square. So that means, according to Pythagoras theorem, AB is the, according to Pythagoras theorem, AB is the hypotenuse. So your figure will be like this. AB is the hypotenuse. See, you have like this. So the right angle is at C. So according to Pythagoras theorem, so we'll conclude like this. So therefore, according to Pythagoras theorem, according to Pythagoras theorem, triangle ABC is a right angle triangle. Is a right angled triangle. Hence it is proved. It is a right angle triangle, hence it is proved. So we proved that it is a right angle triangle. So here A, B, C are the vertices. Now if you see this fifth problem, these three are the vectors. The triangle is formed by the vectors. So now in the fifth problem, you have to take the vectors. So AB vector is 3I. We assume that AB is equal to 3I plus 5j plus 2k. AB side. So another side is BC. So if you take the triangle like this, AB and then C, ABC like this. One side is A, another side is B, another side is C. So it is like this in the triangle. So let A bar is equal to, what is it, 3I plus 5j plus 2k. So this is the side AB. If you take the triangle as AB, it is the side AB. And then B is equal to 2I minus 3J minus 5K. So this is the side BC. And then next C is minus 5I minus 2J plus 3K. So this is the side AC or CA, like that. AC will take AB. So these are the sides. Already he has given the sides. They are not the points. So directly you will find the length mod AB. So mod of AB. AB side. What is it? Root of 3 square plus 5 square plus 2 square. How much is it? First 25. 25 plus 9 plus 4. 38. So it is root 38. Now in the same way, when you take mod B is equal to root of same thing, 2 square plus minus 3 whole square plus minus 5 whole square. So that is also root 38, and then mod C is equal to mod AC, and this is mod BC. So this is also equal to root of again minus 5 whole square plus minus 2 whole square plus 3 square. So that is also equal to root 38. Since all sides are equal, the triangle is equilateral. Yes, the triangle is equilateral. So we'll write the conclusion. So you must understand the difference between these two. Here these are the vertices and here these are already the sides. So you are directly finding the length. So this is the length of the side AB. So after this we'll conclude like this. Therefore, so since we'll conclude like this here, since mod AB is equal to mod BC is equal to mod CA, all sides are equal in triangle ABC. All sides are equal in triangle ABC. Therefore, the triangle ABC is equilateral. It is equilateral. So that is the conclusion. So the three sides, given sides, equilateral triangle. Now will you please take down this homework. First problem. A is equal to 2I plus 5J plus K. And then B is equal to 4I no, first you take down this problem. Find the unit vector. Find the unit vector in the opposite direction of. Find the unit vector in the opposite direction of A plus B plus C, where A is equal to 2I plus 4J minus 5K, B is equal to I plus J plus K, and then C is equal to J plus 2K. This is very, very important. And then the answer for this is minus 1 by 7 into 3I plus 6J minus 2K. 3I plus 6J minus 2K. Let A is equal to I plus 2J plus 3K. And then B is equal to 3I plus J. Find the unit vector. Find the unit vector in the direction of. Find the unit vector in the direction of A plus B. So the answer for this problem is unit vector in the direction of a plus b. So the answer is 1 by root 34 4i plus 3j plus 3k. This is your answer.